if you extrapolate the curves that we've had so far, right? If you say, well, I don't know, we're starting to get to like PhD level, and last year we were at undergraduate level, and the year before we were at like the level of a high school student. Again, you can quibble with at what tasks and for what. We're still missing modalities, but those are being added, like computer use was added, like image generation has been added. If you just kind of like eyeball the rate at which these capabilities are increasing, it does make you think that we'll get there by 2026 or 2027. I think there are still worlds where it doesn't happen in 100 years. The number of those worlds is rapidly decreasing. We are rapidly running out of truly convincing blockers, truly compelling reasons why this will not happen in the next few years. The scale up is very quick. Like we do this today. We make a model and then we deploy thousands, maybe tens of thousands of instances of it. I think by the time, certainly within 2 to 3 years, whether we have these super powerful AIs or not, clusters are going to get to the size where you'll be able to deploy millions of these. I am optimistic about meaning. I worry about economics and the concentration of power. That's actually what I worry about more, the abuse of power.
And AI increases the amount of power in the world. And if you concentrate that power and abuse that power, it can do immeasurable damage.
Yes, it's very frightening. It's very frightening.
The following is a conversation with Dario Amodei, CEO of Anthropic, the company that created Claude, that is currently and often at the top of most LLM benchmark leaderboards. On top of that, Dario and the Anthropic team have been outspoken advocates for taking the topic of AI safety very seriously. And they have continued to publish a lot of fascinating AI research on this and other topics. I'm also joined afterwards by 2 other brilliant people from Anthropic. First, Amanda Askell, who is a researcher working on alignment and fine-tuning of Claude, including the design of Claude's character and personality. A few folks told me she has probably talked with Claude more than any human at Anthropic. So she was definitely a fascinating person to talk to about prompt engineering and practical advice on how to get the best out of Claude. After that, Chris Olah stopped by for a chat. He's one of the pioneers of the field of mechanistic interpretability, which is an exciting set of efforts that aims to reverse engineer neural networks to figure out what's going on inside, inferring behaviors from neural activation patterns inside the network. This is a very promising approach for keeping future superintelligent AI systems safe. For example, by detecting from the activations when the model is trying to deceive the human it is talking to. This is a Lex Fridman podcast. To support it, please check out our sponsors in the description. And now, dear friends, here's Dario Amodei. Let's start with the big idea of scaling laws and the scaling hypothesis. What is it? What is its history? And where do we stand today?
So I can only describe it as it relates to kind of my own experience, but I've been in the AI field for about 10 years. And it was something I noticed very early on. So I first joined the AI world when I was working at Baidu with Andrew Ng in late 2014, which is almost exactly 10 years ago now. And the first thing we worked on was speech recognition systems. And in those days, I think deep learning was a new thing. It had made lots of progress, but everyone was always saying, we don't have the algorithms we need to succeed. We're only matching a tiny fraction. There's so much we need to kind of discover algorithmically. We haven't found the picture of how to match the human brain. And when, in some ways it was fortunate, I was kind of, you can have almost beginner's luck, right? I was like a newcomer to the field. And, I looked at the neural net that we were using for speech, the recurrent neural networks, and I said, I don't know, what if you make them bigger and give them more layers? And what if you scale up the data along with this, right? I just saw these as like independent dials that you could turn. And I noticed that the model started to do better and better as you gave them more data, as you made the models larger, as you trained them for longer. And I didn't measure things precisely in those days, but along with colleagues, we very much got the informal sense that the more data and the more compute and the more training you put into these models, the better they perform. And so initially my thinking was, hey, maybe that is just true for speech recognition systems, right? Maybe that's just one particular quirk, one particular area. I think it wasn't until 2017 when I first saw the results from GPT-1 that it clicked for me that language is probably the area in which we can do this. We can get trillions of words of language data. We can train on them. And the models we were training in those days were tiny. You could train them on 1 to 8 GPUs, whereas, now we train jobs on tens of thousands, soon going to hundreds of thousands of GPUs. And so when I saw those two things together, and there were a few people like Ilya Sutskever who you've interviewed who had somewhat similar views, right? He might have been the first one, although I think a few people came to similar views around the same time, right? There was, Rich Sutton's Bitter Lesson. There was Gorin wrote about the scaling hypothesis. But I think somewhere between 2014 and 2017 was when it really clicked for me, when I really got conviction that, hey, we're going to be able to do these incredibly wide cognitive tasks if we just scale up the models. And at every stage of scaling, there are always arguments. And, when I first heard them, honestly, I thought, probably I'm the one who's wrong. And, all these experts in the field are right. They know the situation better than I do, right? There's, the Chomsky argument about like, you can get syntactics, but you can't get semantics. There was this idea, you can make a sentence make sense, but you can't make a paragraph make sense. The latest one we have today is, we're going to run out of data, or the data isn't high quality enough, or models can't reason. And every time we manage to either find a way around, or scaling just is the way around. Sometimes it's one, sometimes it's the other. And so I'm now at this point. I still think it's always quite uncertain. We have nothing but inductive inference to tell us that the next few years are going to be like the last 10 years. But I've seen the movie enough times. I've seen the story happen for enough times to really believe that probably the scaling is going to continue, and that there's some magic to it that we haven't really explained on a theoretical basis yet.
And of course, the scaling here is bigger networks, bigger data, bigger compute.
Yes.
All of those.
In particular, linear scaling up of bigger networks, bigger training times, and more data. So all of these things, almost like a chemical reaction. You have 3 ingredients in the chemical reaction, and you need to linearly scale up the 3 ingredients. If you scale up one, not the others, you run out of the other reagents, and the reaction stops. But if you scale up everything in series, then the reaction can proceed.
And of course, now that you have this kind of empirical science / art, you can apply it to other more nuanced things like scaling laws applied to interpretability, or scaling laws applied to post-training, or just seeing how does this thing scale. But the big scaling law, I guess the underlying scaling hypothesis, has to do with big networks, big data leads to intelligence.
Yeah, we've documented scaling laws in lots of domains other than language, right? So initially, the paper we did that first showed it was in early 2020, where we first showed it for language. There was then some work late in 2020 where we showed the same thing for other modalities like images, video, text to image, image to text, math, that they all had the same pattern. And you're right. Now, there are other stages like post-training, or there are new types of reasoning models. And in all of those cases that we've measured, we see similar types of scaling laws.
A bit of a philosophical question, but what's your intuition about why bigger is better in terms of network size and data size? Why does it lead to more intelligent models?
So in my previous career as a biophysicist, so I did physics undergrad and then biophysics in grad school. So I think back to what I know as a physicist, which is actually much less than what some of my colleagues at Anthropic have in terms of expertise in physics. There's this concept called the 1 over F noise and 1 over X distributions, where often just like if you add up a bunch of natural processes, you get a Gaussian. If you add up a bunch of kind of differently distributed natural processes, if you take a probe and hook it up to a resistor, the distribution of the thermal noise in the resistor goes as 1 over the frequency. It's some kind of natural convergent distribution, and I think what it amounts to is that if you look at a lot of things that are produced by some natural process that has a lot of different scales, right? Not a Gaussian, which is kind of narrowly distributed, but if I look at kind of like large and small fluctuations that lead to electrical noise, they have this decaying 1 over x distribution. And so now I think of like patterns in the physical world, right? Or in language. If I think about the patterns in language, there are some really simple patterns. Some words are much more common than others, like the. Then there's basic noun-verb structure. Then there's the fact that, nouns and verbs have to agree. They have to coordinate. And there's the higher level sentence structure. Then there's the thematic structure of paragraphs. And so the fact that there's this regressing structure, you can imagine that as you make the networks larger, first they capture the really simple correlations, the really simple patterns, and there's this long tail of other patterns. And if that long tail of other patterns is really smooth, like it is with the 1 over f noise in physical processes like resistors, then you can imagine as you make the network larger, it's kind of capturing more and more of that distribution. And so that smoothness gets reflected in how well the models are at predicting and how well they perform. Language is an evolved process, right? We've developed language. We have common words and less common words. We have common expressions and less common expressions. We have ideas, cliches that are expressed frequently, and we have novel ideas. And that process has developed, has evolved with humans over millions of years. And so the guess, and this is pure speculation, would be that there's some kind of long tail distribution of the distribution of these ideas.
So there's the long tail, but also there's the height of the hierarchy of concepts that you're building up. So the bigger the network, presumably you have a higher capacity to...
Exactly. If you have a small network, you only get the common stuff, right? If I take a tiny neural network, it's very good at understanding that, a sentence has to have, verb, adjective, noun, right? But it's terrible at deciding what those verb, adjective, and noun should be and whether they should make sense. If I make it just a little bigger, it gets good at that. Then suddenly it's good at the sentences, but it's not good at the paragraphs. And so these rarer and more complex patterns get picked up as I add more capacity to the network.
Well, the natural question then is, what's the ceiling of this?
Yeah.
Like, how complicated and complex is the real world? How much stuff is there to learn?
I don't think any of us knows the answer to that question. My strong instinct would be that there's no ceiling below the level of humans, right? We humans are able to understand these various patterns. And so that makes me think that if we continue to, scale up these models to kind of develop new methods for training them and scaling them up, that will at least get to the level that we've gotten to with humans. There's then a question of, how much more is it possible to understand than humans do? How much is it possible to be smarter and more perceptive than humans? I would guess the answer has got to be domain dependent. If I look at an area like biology, and, I wrote this essay, Machines of Loving Grace, it seems to me that humans are struggling to understand the complexity of biology, right? If you go to Stanford or to Harvard or to Berkeley, you have whole departments of, folks trying to study, like the immune system or metabolic pathways. And each person understands only a tiny part of it, specializes, and they're struggling to combine their knowledge with that of other humans. And so I have an instinct that there's a lot of room at the top for AIs to get smarter. If I think of something like materials in the physical world, or like addressing conflicts between humans or something like that, I mean, it may be there's only some of these problems are not intractable but much harder, and it may be that there's only so well you can do at some of these things, right? Just like with speech recognition, there's only so clear I can hear your speech. So I think in some areas, there may be ceilings in that are very close to what humans have done. In other areas, those ceilings may be very far away. And I think we'll only find out when we build these systems. It's very hard to know in advance. We can speculate, but we can't be sure.
And in some domains, the ceiling might have to do with human bureaucracies and things like this, as you write about.
Yes.
So humans fundamentally have to be part of the loop. That's the cause of the ceiling, not maybe the limits of the intelligence.
Yeah, I think in many cases, in theory, technology could change very fast. For example, all the things that we might invent with respect to biology But remember, there's a clinical trial system that we have to go through to actually administer these things to humans. I think that's a mixture of things that are unnecessary and bureaucratic and things that kind of protect the integrity of society. And the whole challenge is that it's hard to tell. It's hard to tell what's going on. It's hard to tell which is which, right? My view is definitely, I think, in terms of drug development, my view is that we're too slow and we're too conservative. But certainly, if you get these things wrong, it's possible to risk people's lives by being too reckless. And so at least some of these human institutions are in fact protecting people. So it's all about finding the balance. I strongly suspect that balance is kind of more on the side of pushing to make things happen faster, but there is a balance.
If we do hit a limit, if we do hit a slowdown in the scaling laws, what do you think would be the reason? Is it compute limited, data limited? Is it something else? Idea limited?
So a few things. Now we're talking about hitting the limit before we get to the level of humans and the skill of humans. So I think one that's popular today, and I think could be a limit that we run into. Like most of the limits, I would bet against it, but it's definitely possible. Is we simply run out of data. There's only so much data on the internet, and there's issues with the quality of the data. Right? You can get hundreds of trillions of words on the internet, but a lot of it is repetitive, or it's search engine optimization drivel, or maybe in the future it'll even be text generated by AIs itself. And so I think there are limits to what can be produced in this way. That said, we, and I would guess other companies, are working on ways to make data synthetic, where you can use the model to generate more data of the type that you have already, or even generate data from scratch. If you think about what was done with DeepMind's AlphaGo Zero, they managed to get a bot all the way from no ability to play Go whatsoever to above human level just by playing against itself. There was no example data from humans required in the AlphaGo Zero version of it. The other direction, of course, is these reasoning models that do chain of thought and stop to think, and reflect on their own thinking. In a way, that's another kind of synthetic data coupled with reinforcement learning. So my guess is with one of those methods, we'll get around the data limitation, or there may be other sources of data that are available. We could just observe that even if there's no problem with data, as we start to scale models up, they just stop getting better. It seemed to be a reliable observation that they've gotten better. That could just stop at some point for a reason we don't understand. The answer could be that we need to invent some new architecture. There have been problems in the past with say numerical stability of models, where it looked like things were leveling off, but actually, when we found the right unblocker, they didn't end up doing so. So perhaps there's some new optimization method or some new technique we need to unblock things. I've seen no evidence of that so far, but if things were to slow down, that perhaps could be one reason.
What about the limits of compute? Meaning the expensive nature of building bigger and bigger data centers.
So right now, I think most of the frontier model companies, I would guess, are operating in roughly $1 billion scale, plus or minus a factor of 3. Right, those are the models that exist now or are being trained now. I think next year we're going to go to a few billion, and then 2026, we may go to, above 10 billion. And probably by 2027, there are ambitions to build $100 billion clusters. And I think all of that actually will happen. There's a lot of determination to build the compute to do it within this country. And I would guess that it actually does happen. Now, if we get to 100 billion, that's still not enough compute. That's still not enough scale. Then either we need even more scale, or we need to develop some way of doing it more efficiently, of shifting the curve. I think between all of these, one of the reasons I'm bullish about powerful AI happening so fast is just that if you extrapolate the next few points on the curve, we're very quickly getting towards human level ability, right? Some of the new models that we developed, some reasoning models that have come from other companies, they're starting to get to what I would call the PhD or professional level, right? If you look at their coding ability, the latest model we released, Sonnet 3.5, the new or updated version, it gets something like 50% on Swebench. And Swebench is an example of a bunch of professional real-world software engineering tasks. At the beginning of the year, I think the state of the art was 3 or 4%. So in 10 months, we've gone from 3% to 50% on this task. And I think in another year, we'll probably be at 90%. I mean, I don't know, but might even be less than that. We've seen similar things in graduate level math, physics, and biology from models like OpenAI's O1. If we just continue to extrapolate this, right, in terms of skill that we have, I think if we extrapolate the straight curve, within a few years, we will get to these models being, above the highest professional level in terms of humans. Now, will that curve continue? You've pointed to, and I've pointed to, a lot of reasons why, possible reasons why that might not happen. But if the extrapolation curve continues, that is the trajectory we're on.
So Anthropic has several competitors. It'd be interesting to get your sort of view of it all. OpenAI, Google, XAI, Meta. What does it take to win in the broad sense of win in the space?
Yeah, so I want to separate out a couple things, right? So, Anthropic's mission is to kind of try to make this all go well, right? And we have a theory of change called race to the top, right? Race to the top is about trying to push the other players to do the right thing by setting an example. It's not about being the good guy. It's about setting things up so that all of us can be the good guy. I'll give a few examples of this. Early in the history of Anthropic, one of our co-founders, Chris Olah, who I believe you're interviewing soon, he's the co-founder of the field of mechanistic interpretability, which is an attempt to understand what's going on inside AI models. So we had him and one of our early teams focus on this area of interpretability, which we think is good for making models safe and transparent. For 3 or 4 years, that had no commercial application whatsoever. It still doesn't today. We're doing some early betas with it, and probably it will eventually, but this is a very, very long research bet, and one in which we've built in public and shared our results publicly. And we did this because, we think it's a way to make models safer. An interesting thing is that as we've done this, other companies have started doing it as well. In some cases, because they've been inspired by it. In some cases, because they're worried that, if other companies are doing this that look more responsible, they want to look more responsible too. No one wants to look like the irresponsible actor. And so they adopt this. They adopt this as well. When folks come to Anthropic, interpretability is often a draw, and I tell them, the other places you didn't go, tell them why you came here. And then you see soon that there's interpretability teams elsewhere as well. And in a way, that takes away our competitive advantage because it's like, they now others are doing it as well. But it's good for the broader system. And so we have to invent some new thing that we're doing that others aren't doing as well. And the hope is to basically bid up the importance of doing the right thing. And it's not about us in particular, right? It's not about having one particular good guy. Other companies can do this as well. If they join the race to do this, that's the best news ever, right? It's about kind of shaping the incentives to point upward instead of shaping the incentives to point downward.
And we should say this example of the field of mechanistic interpretability is just a rigorous, non-hand-wavy way of doing AI safety.
Yes.
Or it's tending that way.
Trying to. I mean, I think we're still early in terms of our ability to see things, but I've been surprised at how much we've been able to look inside these systems and understand what we see, right? Unlike with the scaling laws where it feels like there's some, law that's driving these models to perform better, on the inside, the models aren't, there's no reason why they should be designed for us to understand them, right? They're designed to operate. They're designed to work, just like the human brain or human biochemistry. They're not designed for a human to open up the hatch, look inside, and understand them. But we have found, and you can talk in much more detail about this to Chris, that when we open them up, when we do look inside them, we find things that are surprisingly interesting.
And as a side effect, you also get to see the beauty of these models. You get to explore the sort of the beautiful nature of large neural networks through the MECINTERP kind of methodology.
I'm amazed at how clean it's been.
Yeah.
I'm amazed at things like induction heads. I'm amazed at things like that we can, use sparse autoencoders to find these directions within the networks, and that the directions correspond to these very clear concepts. We demonstrated this a bit with the Golden Gate Bridge Claude. So this was an experiment where we found a direction inside one of the neural network's layers that corresponded to the Golden Gate Bridge. And we just turned that way up. And so we released this model as a demo. It was kind of half a joke for a couple days, but it was illustrative of the method we developed. And you could take the Golden Gate, you could take the model, you could ask it about anything. It would be like you could say, "How was your day?" And anything you asked, because this feature was activated, it would connect to the Golden Gate Bridge. So it would say, I'm feeling relaxed and expansive, much like the arches of the Golden Gate Bridge, or
it would masterfully change topic to the Golden Gate Bridge and integrate it. There was also a sadness to it, to the focus it had on the Golden Gate Bridge. I think people quickly fell in love with it. I think so. People already miss it because it was taken down, I think, after a day.
Somehow these interventions on the model, where you kind of adjust its behavior, somehow emotionally made it seem more human than any other version of the model.
A strong personality, strong identity.
It has a strong personality. It has these kind of like obsessive interests. We can all think of someone who's like obsessed with something. Yeah. So it does make it feel somehow a bit more human.
Let's talk about the present. Let's talk about Claude. So this year, a lot has happened. In March, Claude 3, Opus, Sonnet, Haiku were released. Then Claude 3.5, Sonnet in July, with an updated version just now released. And then also Claude 3.5 Haiku was released. Okay. Can you explain the difference between Opus, Sonnet, and Haiku, and how we should think about the different versions?
Yeah. So let's go back to March when we first released these three models. So, our thinking was, different companies produce kind of large and small models, better and worse models. We felt that there was demand both for a really powerful model, and that might be a little bit slower, that you'd have to pay more for, and also for fast, cheap models that are as smart as they can be for how fast and cheap, right? Whenever you want to do some kind of like, difficult analysis, like if I want to write code, for instance, or, I want to brainstorm ideas, or I want to do creative writing, I want the really powerful model. But then there's a lot of practical applications in a business sense where it's like, I'm interacting with a website. I'm like doing my taxes, or I'm, talking to to like a legal advisor, and I want to analyze a contract, or, we have plenty of companies that are just like, I want to do autocomplete on my IDE or something. And for all of those things, you want to act fast and you want to use the model very broadly. So we wanted to serve that whole spectrum of needs. So we ended up with this, this kind of poetry theme. And so what's a really short poem? It's a haiku. Yeah. And so haiku is the small, fast, cheap model that is, was at the time was released surprisingly intelligent for how fast and cheap it was. Sonnet is a medium-sized poem, right? A couple paragraphs. And so Sonnet was the middle model. It is smarter, but also a little bit slower, a little bit more expensive. And Opus, like a magnum opus, is a large work. Opus was the largest, smartest model at the time. So that was the original kind of thinking behind it. And our thinking then was, well, each new generation of models should shift that trade-off curve. So when we release Sonnet 3.5, it has roughly the same, cost and speed as the Sonnet 3 model, but it increased its intelligence to the point where it was smarter than the original Opus 3 model, especially for code, but also just in general. And so now, we've shown results for Haiku 3.5, and I believe Haiku 3.5, the smallest new model, is about as good as Opus 3, the largest old model. Yeah. So basically, the aim here is to shift the curve, and then at some point, there's going to be an Opus 3.5. Now, every new generation of models has its own thing. They use new data. Their personality changes in ways that we kind of, try to steer, but are not fully able to steer. And so there's never quite that exact equivalence where the only thing you're changing is intelligence. We always try and improve other things, and some things change without us knowing or measuring. So it's very much an inexact science. In many ways, the manner and personality of these models is more an art than it is a science.
So what is sort of the reason for the span of time between, say, Claude Opus 3.0 and 3.5? What takes that time, if you can speak to?
Yeah, so there's different processes. There's pre-training, which is just kind of the normal language model training, and that takes a very long time. That uses these days tens of thousands, sometimes many tens of thousands of GPUs or TPUs or Trainium, or what we use different platforms, but accelerator chips. Often training for months. There's then a kind of post-training phase where we do reinforcement learning from human feedback, as well as other kinds of reinforcement learning. That phase is getting larger and larger now, and often that's less of an exact science. It often takes effort to get it right. Models are then tested with some of our early partners to see how good they are. And they're then tested both internally and externally for their safety, particularly for catastrophic and autonomy risks. So we do internal testing according to our responsible scaling policy, which I could talk more about that in detail. And then we have an agreement with the US and the UK AI Safety Institute, as well as other third-party testers in specific domains, to test the models for what are called CBRN risks: chemical, biological, radiological, and nuclear, which are, we don't think that models pose these risks seriously yet, but every new model we want to evaluate to see if we're starting to get close to some of these more dangerous capabilities. So those are the phases, and then then it just takes some time to get the model working in terms of inference and launching it in the API. So there's just a lot of steps to actually making a model work. And of course, we're always trying to make the processes as streamlined as possible, right? We want our safety testing to be rigorous, but we want it to be rigorous and to be automatic, to happen as fast as it can without compromising on rigor. Same with our pre-training process and our post-training process. So, it's just like building anything else. It's just like building airplanes. You want to make them safe, but you want to make the process streamlined. And I think the creative tension between those is an important thing in making the models work.
Yeah, rumor on the street, I forget who was saying that Anthropic has really good tooling. So probably a lot of the challenge here is on the software engineering side, is to build the tooling to have a efficient, low friction interaction with the infrastructure.
You would be surprised how much of the challenges of building these models comes down to software engineering, performance engineering. From the outside, you might think, oh man, we had this eureka breakthrough, right? This movie with the science, we discovered it, we figured it out. But I think all things, even incredible discoveries, like they almost always come down to the details, and often super boring details. I can't speak to whether we have better tooling than other companies. I mean, I haven't been at those other companies, at least not recently. But it's certainly something we give a lot of attention to.
I don't know if you can say, but from Claude 3 to Claude 3.5, is there any extra pre-training going on, or is it mostly focused on the post-training? There's been leaps in performance.
Yeah, I think at any given stage, we're focused on improving everything at once. Just naturally, like there are different teams. Each team makes progress in a particular area in making a particular, their particular segment of the relay race better. And it's just natural that when we make a new model, we put all of these things in at once.
So the data you have, like the preference data you get from RLHF, is that applicable? Is there ways to apply it to newer models as they get trained up?
Yeah, preference data from old models sometimes gets used for new models, although of course it performs somewhat better when it's trained on the new models. Note that we have this constitutional AI method such that we don't only use preference data, we kind of there's also a post-training process where we train the model against itself. And there's, new types of post-training the model against itself that are used every day. So it's not just RLHF, it's a bunch of other methods as well. Post-training, I think, is becoming more and more sophisticated.
Well, what explains the big leap in performance for the new Sonnet 3.5? I mean, at least in the programming side. And maybe this is a good place to talk about benchmarks. What does it mean to get better? It's just the number went up. But, I program, but I also love programming. And Claude 3.5 through Cursor is what I use to assist me in programming. And there was, at least experientially, anecdotally, it's gotten smarter at programming. So what does it take to get it smarter?
We observed that as well, by the way. There were a couple very strong engineers here at Anthropic who all previous code models, both produced by us and produced by all the other companies, hadn't really been useful to them. They said, maybe this is useful to beginner. It's not useful to me. But Sonnet 3.5, the original one, for the first time, they said, oh my God, this helped me with something that, that it would have taken me hours to do. This is the first model that has actually saved me time. So again, the waterline is rising. And then I think, the new Sonnet has been even better. In terms of what it takes, I mean, I'll just say it's been across the board. It's in the pre-training, it's in the post-training, it's in various evaluations that we do. We've observed this as well. And if we go into the details of the benchmark, so SWE-bench is basically, since you're a programmer, you'll be familiar with like pull requests and, just pull requests are like, a sort of atomic unit of work. You could say I'm implementing one thing. And so SWE-bench actually gives you kind of a real world situation where the code base is in a current state, and I'm trying to implement something that's described in language. We have internal benchmarks where we measure the same thing, and you say, just give the model free rein to do anything, run anything, edit anything. How well is it able to complete these tasks? And it's that benchmark that's gone from it can do it 3% of the time to it can do it about 50% of the time. So I actually do believe that if we get, you can game benchmarks, but I think if we get to 100% on that benchmark in a way that isn't kind of like overtrained or gamed for that particular benchmark, probably represents a real and serious increase in kind of programming ability. And I would suspect that if we can get to 95%, that it will represent ability to autonomously do a significant fraction of software engineering tasks.
Well, ridiculous timeline question. When is Claude Opus 3.5 coming out?
Not giving an exact date, but as far as we know, the plan is still to have a Claude 3.5 Opus.
Are we going to get it before GTA 6 or no?
Like Duke Nukem Forever? What was that game? There was some game that was delayed 15 years. Right. Was that Duke Nukem Forever?
Yeah, and I think GTA is now just releasing trailers.
It's only been 3 months since we released the first Sonnet.
Yeah, it's the incredible pace of release.
It just tells you about the pace.
Yeah.
The expectations for when things are going to come out.
So what about 4.0? So how do you think about sort of as these models get bigger and bigger about versioning and also just versioning in general? Why Sonnet 3.5 updated with the date? Why not Sonnet 3.6, which a lot of people are calling it?
Naming is actually an interesting challenge here, right? Yeah. Because I think a year ago, most of the model was pre-training. And so you could start from the beginning and just say, okay, we're going to have models of different sizes. We're going to train them all together. And, we'll have a family of naming schemes, and then we'll put some new magic into them. And then, we'll have the next generation. The trouble starts already when some of them take a lot longer than others to train, right? That already messes up your time a little bit. But as you make big improvements in pre-training, then you suddenly notice, I can make better pre-trained model, and that doesn't take very long to do. But clearly it has the same, size and shape of previous models. So I think those two together, as well as the timing issues, any kind of scheme you come up with, the reality tends to kind of frustrate that scheme, right? It tends to kind of break out of the scheme. It's not like software where you can say, this is like, 3.7, this is 3.8. No, you have models with different trade-offs. You can change some things in your models. You can change other things. Some are faster and slower at inference. Some have to be more expensive. Some have to be less expensive. And so I think all the companies have struggled with this. Yeah. I think we did very, I think we were in a good position in terms of naming when we had Haiku, Sonnet, and Opus.
It was great start.
And we're trying to maintain it, but it's not perfect. So we'll try and get back to the simplicity, but it just the nature of the field. I feel like no one's figured out naming. It's somehow a different paradigm from like normal software, and so we just. None of the companies have been perfect at it. It's something we struggle with surprisingly much relative to how trivial it is to for the grand science of training the models.
So from the user side, the user experience of the updated Sonnet 3.5 is just different than the previous June 2024 Sonnet 3.5. It would be nice to come up with some kind of labeling that embodies that, because people talk about Sonnet 3.5, but now there's a different one. And so how do you refer to the previous one and the new one? And it when there's a distinct improvement, it just makes conversation about it just challenging.
Yeah. I definitely think this question of there are lots of properties of the models that are not reflected in the benchmarks. I think that's definitely the case, and everyone agrees. And not all of them are capabilities. Some of them are, models can be polite or brusque. They can be, very reactive, or they can ask you questions. They can have what feels like a warm personality or a cold personality. They can be boring, or they can be very distinctive, like Golden Gate Claude was. And we have a whole team kind of focused on, I think we call it Claude character. Amanda leads that team, and we'll talk to you about that. But it's still a very inexact science. And often we find that models have properties that we're not aware of. The fact of the matter is that you can, talk to a model 10,000 times, and there are some behaviors you might not see. Just like with a human, right? I can know someone for a few months and, not know that they have a certain skill, or not know that there's a certain side to them. And so I think we just have to get used to this idea, and we're always looking for better ways of testing our models to demonstrate these capabilities, and also to decide which are the personality properties we want models to have and which we don't want to have. That itself, the normative question, is also super interesting.
I got to ask you a question from Reddit.
From Reddit. Oh boy.
There's just this fascinating, to me at least, it's a psychological, social phenomenon where people report that Claude has gotten dumber for them over time. And so the question is, does the user complaint about the dumbing down of Claude 3.5 Sonnet hold any water? So are these anecdotal reports a kind of social phenomena, or is there any cases where Claude would get dumber?
So this actually doesn't apply. This isn't just about Claude. I believe I've seen these complaints for every foundation model produced by a major company. People said this about GPT-4. They said it about GPT-4 Turbo. So a couple things. One, the actual weights of the model, right? The actual brain of the model, that does not change unless we introduce a new model. There are just a number of reasons why it would not make sense practically to be randomly substituting in new versions of the model. It's difficult from an inference perspective, and it's actually hard to control all the consequences of changing the weights of the model. Let's say you wanted to fine-tune the model to be like, I don't know, to say certainly less, which, an old version of Sonnet used to do. You actually end up changing 100 things as well. So we have a whole process for it, and we have a whole process for modifying the model. We do a bunch of testing on it. We do a bunch of user testing in early customers. So we both have never changed the weights of the model without telling anyone, and it wouldn't, certainly in the current setup, it would not make sense to do that. Now, there are a couple things that we do occasionally do. One is sometimes we run A/B tests, but those are typically very close to when a model is being released, and for a very small fraction of time. Like the day before the new Sonnet 3.5 I agree. We should we should have had a better name. It's just clunky to refer to it. There were some comments from people that like it's gotten a lot better, and that's because a fraction were exposed to an A/B test for those 1 or 2 days. The other is that occasionally the system prompt will change. The system prompt can have some effects, although it's unlikely to dumb down models. It's unlikely to make them dumber. And we've seen that while these two things, which I'm listing to be very complete, happen quite infrequently. The complaints about for us and for other model companies about the model changed, the model isn't good at this, the model got more censored, the model was dumbed down. Those complaints are constant. And so I don't want to say like people are imagining it or anything, but like the models are for the most part not changing. If I were to offer a theory, I think it actually relates to one of the things I said before, which is that models are very complex and have many aspects to them. And so often, if I ask the model a question, if I'm like do task X versus can you do task X, the model might respond in different ways. And so there are all kinds of subtle things that you can change about the way you interact with the model that can give you very different results. To be clear, this itself is like a failing by us and by the other model providers that the models are just often sensitive to like small changes in wording. It's yet another way in which the science of how these models work is very poorly developed. And so, if I go to sleep one night and I was like talking to the model in a certain way, and I like slightly change the phrasing of how I talk to the model, I could get different results. So that's one possible way. The other thing is, man, it's just hard to quantify this stuff. It's hard to quantify this stuff. I think people are very excited by new models when they come out, and then as time goes on, they become very aware of the limitations. So that may be another effect. But that's all a very long-winded way of saying, for the most part, with some fairly narrow exceptions, the models are not changing.
I think there is a psychological effect. You should start getting used to it. The baseline raises. Like when people first gotten Wi-Fi on airplanes, it's like amazing. It's like amazing. Magic.
Yeah.
And then
now
and then
I'm
you
like,
start
I can't get this thing to work.
Yeah.
This is such a piece of crap.
Exactly. So then it's easy to have the conspiracy theory of they're making Wi-Fi slower and slower. This is probably something I'll talk to Amanda much more about. But another Reddit question. When will Claude stop trying to be my puritanical grandmother, imposing its moral worldview on me as a paying customer? And also, what is the psychology behind making Claude overly apologetic? So this kind of reports about the experience, a different angle on the frustration. It has to do with the character.
Yeah, so a couple points on this first. One is like things that people say on Reddit and Twitter or X or whatever it is. There's actually a huge distribution shift between like the stuff that people complain loudly about on social media and what actually kind of like, statistically users care about and that drives people to use the models. Like people are frustrated with, things like, the model not writing out all the code or the model, just not being as good at code as it could be, even though it's the best model in the world on code. I think the majority of things are about that. But certainly a kind of vocal minority are, kind of raise these concerns, right? Are frustrated by the model refusing things that it shouldn't refuse, or like apologizing too much, or just having these kind of like annoying verbal tics. The second caveat, and I just want to say this like super clearly because I think it's like some people don't know it, others like kind of know it but forget it. Like it is very difficult to control across the board how the models behave. You cannot just reach in there and say, oh, I want the model to like apologize less. Like you can do that. You can include trading data that says like, oh, the model should like apologize less. But then in some other situation, they end up being like super rude or like overconfident in a way that's like misleading people. So there are all these trade-offs. For example, another thing is if there was a period during which models, ours, and I think others as well, were too verbose, right? They would like repeat themselves. They would say too much. You can cut down on the verbosity by penalizing the models for just talking for too long. What happens when you do that, if you do it in a crude way, is when the models are coding, sometimes they'll say, rest of the code goes here, right? Because they've learned that that's a way to economize and that they see it. And And then so that leads the model to be so-called lazy in coding, where they're just like, you can finish the rest of it. Yeah. It's not because we want to, save on compute, or because, the models are lazy and, during winter break, or any of the other kind of conspiracy theories that have come up. It's just very hard to control the behavior of the model, to steer the behavior of the model in all circumstances at once. You can there's this whack-a-mole aspect where you push on one thing and these other things start to move as well that you may not even notice or measure. And so one of the reasons that I care so much about kind of grand alignment of these AI systems in the future is actually these systems are actually quite unpredictable. They're actually quite hard to steer and control. And this version we're seeing today of you make one thing better, it makes another thing worse. I think that's like a present day analog of future control problems in AI systems that we can start to study today, right? I think that difficulty in steering the behavior and in making sure that if we push an AI system in one direction, it doesn't push it in another direction in some other ways that we didn't want. I think that's kind of an early sign of things to come. And if we can do a good job of solving this problem, right? Of you ask the model to make and distribute smallpox, and it says no, but it's willing to help you in your graduate level virology class. How do we get both of those things at once? It's hard. It's very easy to go to one side or the other, and it's a multidimensional problem. And so I think these questions of shaping the model's personality, I think they're very hard. I think we haven't done perfectly on them. I think we've actually done the best of all the AI companies, but still so far from perfect. And I think if we can get this right, if we can control control the false positives and false negatives in this very kind of controlled present day environment, we'll be much better at doing it for the future, when our worry is, will the models be super autonomous? Will they be able to, make very dangerous things? Will they be able to autonomously, build whole companies? And are those companies aligned? So I think of this present task as both vexing, but also good practice for the future.
What's the current best way of gathering sort of user feedback, not anecdotal data, but just large scale data about pain points or the opposite of pain points, positive things, so on? Is it internal testing? Is it a specific group testing, A/B testing? What works?
So typically we'll have internal model bashings where all of Anthropic is almost 1,000 people. People just try and break the model. They try and interact with it various ways. We have a suite of evals for, is the model refusing in ways that it couldn't? I think we even had a certainly eval because, our model, again, at one point, model had this problem where it had this annoying tick where it would respond to a wide range of questions by saying, certainly, I can help you with that. Certainly, I would be happy to do that. Certainly, this is correct. And so we had a certainly eval, which is how often does the model say certainly?
Yeah.
But look, this is just a whack-a-mole. What if it switches from certainly to definitely? So every time we add a new eval, and we're always evaluating for all of the old things. So we have hundreds of these evaluations, but we find that there's no substitute for a human interacting with it. And so it's very much like the ordinary product development process. We have hundreds of people within Anthropic bash the model. Then we do external A/B tests. Sometimes we'll run tests with contractors. We pay contractors to interact with the model. So you put all of these things together and it's still not perfect. You still see behaviors that you don't quite want to see, right? You still see the model refusing things that it just doesn't make sense to refuse. But I think trying to solve this challenge, right? Trying to stop the model from doing, genuinely bad things that, everyone agrees it shouldn't do, right? Everyone agrees that, the model shouldn't talk about, I don't know, child abuse material, right? Everyone agrees the model shouldn't do that. But at the same time that it doesn't refuse in these dumb and stupid ways. I think drawing that line as finely as possible, approaching perfectly is still a challenge, and we're getting better at it every day, but there's a lot to be solved. And again, I would point to that as as an indicator of a challenge ahead in terms of steering much more powerful models.
Do you think Claude 4.0 is ever coming out?
I don't want to commit to any naming scheme, because if I say here we're going to have Claude 4 next year, and then then we decide that we should start over because there's a new type of model. I don't want to commit to it. I would expect in a normal course of business that Claude 4 would come after Claude 3.5, but you never know in this wacky field, right?
But the sort of this idea of scaling is continuing.
Scaling is continuing. There will definitely be more powerful models coming from us than the models that exist today. That is certain. Or if there aren't, we've deeply failed as a company.
Okay, can you explain the responsible scaling policy and the AI safety level standards, ASL levels?
As much as I'm excited about the benefits of these models, and we'll talk about that if we talk about machines of loving grace, I'm worried about the risks, and I continue to be worried about the risks. No one should think that machines of loving grace was me saying I'm no longer worried about the risks of these models. I think they're two sides of the same coin. The power of the models and their ability to solve all these problems in biology, neuroscience, economic development, governance and peace, large parts of the economy, those come with risks as well, right? With great power comes great responsibility, right? That's the two are paired. Things that are powerful can do good things and they can do bad things. I think of those risks as being in several different categories. Perhaps the two biggest risks that I think about, and that's not to say that there aren't risks today that are important, but when I think of the things that would happen on the grandest scale, one is what I call catastrophic misuse. These are misuse of the models in domains like cyber, bio, radiological, nuclear, right? Things that could harm or even kill thousands, even millions of people if they really, really go wrong. These are the number one priority to prevent. And here I would just make a simple observation, which is that the models, if I look today at people who have done really bad things in the world, I think actually humanity has been protected by the fact that the overlap between really smart, well-educated people and people who want to do really horrific things has generally been small. Let's say I'm someone who, I have a PhD in this field, I have a well-paying job. There's so much to lose. Why do I want to even assuming I'm completely evil, which most people are not? Why would such a person risk their life, risk their legacy, their reputation to do something truly, truly evil? If we had a lot more people like that, the world would be a much more dangerous place. And so my worry is that by being a much more intelligent agent, AI could break that correlation. And so I do have serious worries about that. I believe we can prevent those worries. But I think as a counterpoint to machines of loving grace, I want to say that there's still serious risks. And the second range of risks would be the autonomy risks, which is the idea that models might on their own, particularly as we give them more agency than they've had in the past, particularly as we give them supervision over wider tasks like, writing whole code bases, or someday even, effectively operating entire companies. They're on a long enough leash. Are they doing what we really want them to do? It's very difficult to even understand in detail what they're doing, let alone control it. And like I said, these early signs that it's hard to perfectly draw the boundary between things the model should do and things the model shouldn't do. If you go to one side, you get things that are annoying and useless, and you go to the other side, you get other behaviors. If you fix one thing, it creates other problems. We're getting better and better at solving this. I don't think this is an unsolvable problem. I think this is a science, like the safety of airplanes or the safety of cars or the safety of drugs. I don't think there's any big thing we're missing. I just think we need to get better at controlling these models. And so these are the two risks I'm worried about. And our responsible scaling plan, which I'll recognize as a very long-winded answer to your question.
I love it.
Our responsible scaling plan is designed to address these two types of risks. And so every time we develop a new model, we basically test it for its ability to do both of these bad things. So if I were to back up a little bit, I think we have an interesting dilemma with AI systems where they're not yet powerful enough to present these catastrophes. I don't know if they'll ever prevent these catastrophes. It's possible they won't, but the case for worry, the case for risk is strong enough that we should act now. And they're getting better very, very fast, right? I testified in the Senate that, we might have serious bio risks within 2 to 3 years. That was about a year ago. Things have proceeded apace. So we have this thing where it's like it's surprisingly hard to address these risks because they're not here today. They don't exist. They're like ghosts, but they're coming at us so fast because the models are improving so fast. So how do you deal with something that's not here today, doesn't exist, but is coming at us very fast? So the solution we came up with for that, in collaboration with people like the organization Meter and Paul Cristiano, is okay. What you need for that are you need tests to tell you when the risk is getting close. You need an early warning system, and so every time we have a new model, we test it for its capability to do these CBRN tasks, as well as testing it for, how capable it is of doing tasks autonomously on its own. And in the latest version of our RSP, which we released in the last month or two, the way we test autonomy risks is the AI model's ability to do aspects of AI research itself. Which when the AI models can do AI research, they become kind of truly autonomous. And that threshold is important for a bunch of other ways. And so what do we then do with these tasks? The RSP basically develops what we've called an if-then structure, which is if the models pass a certain capability, then we impose a certain set of safety and security requirements on them. So today's models are what's called ASL2. Models that were ASL1 is for systems that manifestly don't pose any risk of autonomy or misuse. So, for example, a chess playing bot, Deep Blue, would be ASL1. It's just manifestly the case that you can't use Deep Blue for anything other than chess. It was just designed for chess. No one's going to use it to to conduct a masterful cyber attack or to, run wild and take over the world. ASL2 is today's AI systems, where we've measured them and we think these systems are simply not smart enough to autonomously self-replicate or conduct a bunch of tasks, and also not smart enough to provide meaningful information about CBRN risks and how to build CBRN weapons above and beyond what can be known from looking at Google. In fact, sometimes they do provide information, but not above and beyond a search engine, but not in a way that can be stitched together. Not in a way that kind of end to end is dangerous enough. So ASL3 is going to be the point at which the models are helpful enough to enhance the capabilities of non-state actors, right? State actors can already do a lot of, unfortunately, to a high level of proficiency, a lot of these very dangerous and destructive things. The difference is that non-state actors are not capable of it. And so when we get to ASL3, we'll take special security precautions designed to be sufficient to prevent theft of the model by non-state actors and misuse of the model as it's deployed. We'll have to have enhanced filters targeted at these particular areas.
Cyber, bio, nuclear,
and model autonomy, which is less a misuse risk and more a risk of the model doing bad things itself. ASL4, getting to the point where these models could enhance the capability of a already knowledgeable state actor and or become the main source of such a risk. Like if you wanted to engage in such a risk, the main way you would do it is through a model. And then I think ASL4 on the autonomy side, it's some amount of acceleration in AI research capabilities with an AI model. And then ASL5 is where we would get to the models that are kind of truly capable, that it could exceed humanity in their ability to do any of these tasks. And so the point of the if-then structure commitment is basically to say, look, I don't know. I've been working with these models for many years, and I've been worried about risk for many years. It's actually kind of dangerous to cry wolf. It's actually kind of dangerous to say this model is risky, and people look at it and they say this is manifestly not dangerous. Again, it's the delicacy of the risk isn't here today, but it's coming at us fast. How do you deal with that? It's really vexing to a risk planner to deal with it. And so this if-then structure basically says, look, we don't want to antagonize a bunch of people. We don't want to harm our own, our kind of own ability to have a place in the conversation by imposing these very onerous burdens on models that are not dangerous today. So the if-then, the trigger commitment, is basically a way to deal with this. It says you clamp down hard when you can show that the model is dangerous. And of course, what has to come with that is, enough of a buffer threshold that you're not at high risk of kind of missing the danger. It's not a perfect framework. We've had to change it every we came out with a new one just a few weeks ago, and probably going forward we might release new ones multiple times a year because it's hard to get these policies right, like technically, organizationally, from a research perspective. But that is the proposal. If-then commitments and triggers in order to minimize burdens and false alarms now, but really react appropriately when the dangers are here.
What do you think the timeline for ASL3 is, where several of the triggers are fired? And what do you think the timeline is for ASL4?
Yeah, so that is hotly debated within the company. We are working actively to prepare ASL3 security measures as well as ASL3 deployment measures. I'm not going to go into detail, but we've made a lot of progress on both, and we're prepared to be, I think, ready quite soon. I would not be surprised. I would not be surprised at all if we hit ASL3 next year. There was some concern that we might even hit it this year. That's still possible. That could still happen. It's very hard to say, but I would be very, very surprised if it was 2030. I think it's much sooner than that.
So there's protocols for detecting it, the if-then, and then there's protocols for how to respond to it.
Yes.
How difficult is the latter?
I think for ASL3, it's primarily about security and about filters on the model relating to a very narrow set of areas when we deploy the model. Because at ASL3, the model isn't autonomous yet. And so you don't have to worry about, kind of the model itself behaving in a bad way even when it's deployed internally. So I think the ASL3 measures are I won't say straightforward. They're rigorous, but they're easier to reason about. I think once we get to ASL4, we start to have worries about the models being smart enough that they might sandbag tests. They might not tell the truth about tests. We had some results came out about sleeper agents, and there was a more recent paper about, can the models mislead attempts to, sandbag their own abilities, right? Show them, present themselves as being less capable than they are. And so I think with ASL4, there's going to be an important component of using other things than just interacting with the models. For example, interpretability or hidden chains of thought, where you have to look inside the model and verify via some other mechanism that is not as easily corrupted as what the model says, that the model indeed has some property. So we're still working on ASL4. One of the properties of the RSP is that we don't specify ASL4 until we've hit ASL3. Yeah. And I think that's proven to be a wise decision, because even with ASL3, it's hard to know this stuff in detail. And we want to take as much time as we can possibly take to get these things right.
So for ASL3, the bad actor will be the humans.
Yes.
And so there's a little bit more...
For ASL4, it's both, I think.
It's both. And so deception, and that's where mechanistic interpretability comes into play. And hopefully the techniques used for that are not made accessible to the model.
Yeah, I mean, of course, you can hook up the mechanistic interpretability to the model itself, but then you've kind of lost it as a reliable indicator of of the model state. There are a bunch of exotic ways you can think of that it might also not be reliable. Like if the, model gets smart enough that it can like, jump computers and like read the code where you're like looking at its internal state. We've thought about some of those. I think they're exotic enough. There are ways to render them unlikely. But yeah, generally you want to preserve mechanistic interpretability as a kind of verification set or test set that's separate from the training process of the model.
See, I think as these models become better and better at conversation and become smarter, social engineering becomes a threat too, because they that can start being very convincing to the engineers inside companies.
Oh yeah. It's actually like, we've seen lots of examples of demagoguery in our life from humans, and there's a concern that models could do that as well.
One of the ways that Claude has been getting more and more powerful is it's now able to do some agentic stuff. Computer use. There's also an analysis within the sandbox of Claude.ai itself, but let's talk about computer use. That seems to me super exciting, that you can just give Claude a task and it takes a bunch of actions, figures it out, and has access to your computer through screenshots. So can you explain how that works and where that's headed?
Yeah, it's actually relatively simple. So Claude has had for a long time, since Claude 3 back in March, the ability to analyze images and respond to them with text. The only new thing we added is those images can be screenshots of a computer. And in response, we train the model to give a location on the screen where you can click and or buttons on the keyboard you can press in order to take action. And it turns out that with actually not all that much additional training, the models can get quite good at that task. It's a good example of generalization. People sometimes say if you get to low Earth orbit, you're like halfway to anywhere, right? Because of how much it takes to escape the gravity well. If you have a strong pre-trained model, I feel like you're halfway to anywhere in terms of the intelligence space. And so actually it didn't take all that much to get Claude to do this. And you can just set that in a loop. Give the model a screenshot, tell it what to click on, give it the next screenshot, tell it what to click on. And that turns into a full kind of almost 3D video interaction of the model. And it's able to do all of these tasks, right? We showed these demos where it's able to like fill out spreadsheets. It's able to kind of like interact with a website. It's able to, it's able to open all kinds of, programs, different operating systems, Windows, Linux, Mac. So I think all of that is very exciting. I will say, while in theory, there's nothing you could do there that you couldn't have done through just giving the model the API to drive the computer screen. This really lowers the barrier, and there's a lot of folks who either kind of aren't in a position to interact with those APIs, or it takes them a long time to do. It's just the screen is just a universal interface that's a lot easier to interact with, and so I expect over time this is going to lower a bunch of barriers. Now, honestly, the current model it leaves a lot still to be desired, and we were honest about that in the blog, right? It makes mistakes, it misclicks, and we were careful to warn people, hey, this thing isn't. You can't just leave this thing to run on your computer for minutes and minutes. You got to give this thing boundaries and guardrails, and I think that's one of the reasons we released it first in an API form rather than kind of this kind of just hand it to the consumer and give it control of their computer. But I definitely feel that it's important to get these capabilities out there. As models get more powerful, we're going to have to grapple with how do we use these capabilities safely? How do we prevent them from being abused? And I think releasing the model while the capabilities are still limited is very helpful in terms of doing that. I think since it's been released, a number of customers, I think Replit was maybe one of the most quickest to deploy things. Have made use of it in various ways. People have hooked up demos for Windows desktops, Macs, Linux machines. So yeah, it's been very exciting. I think as with anything else, it comes with new exciting abilities, and then with those new exciting abilities, we have to think about how to make the model safe, reliable, do what humans want them to do. I mean, it's the same story for everything, right? Same thing. It's that same tension.
But the possibility of use cases here is just the range is incredible. So, how much to make it work really well in the future? How much do you have to specially kind of go beyond what's the pre-trained models doing? Do more post-training, RLHF, or supervised fine-tuning, or synthetic data just for the agentic
Yeah,
stuff?
I think speaking at a high level, it's our intention to keep investing a lot in making the model better. Like we look at some of the some of the benchmarks where previous models were like, oh, it could do it 6% of the time, and now our model could do it 14 or 22% of the time. And yeah, we want to get up to the human level reliability of 80-90%, just like anywhere else, right? We're on the same curve that we were on with SWE-bench, where I would guess a year from now the models can do this very, very reliably. But you got to start somewhere.
So you think it's possible to get to the human level, 90%, basically doing the same thing you're doing now, or is it has to be special for computer use?
I mean, it depends what you mean by special and special in general. But I generally think the same kinds of techniques that we've been using to train the current model. I expect that doubling down on those techniques in the same way that we have for code, for models in general, for image input, for voice. I expect those same techniques will scale here as they have everywhere else.
But this is giving sort of the power of action to Claude. And so you could do a lot of really powerful things, but you could do a lot of damage also.
Yeah. No, and we've been very aware of that. Look, my view actually is computer use isn't a fundamentally new capability like these CBRN or autonomy capabilities are. It's more like it kind of opens the aperture for the model to use and apply its existing abilities. And so the way we think about it, going back to our RSP, is nothing that this model is doing inherently increases, the risk from an RSP perspective. But as the models get more powerful, having this capability may make it scarier once it has the cognitive capability to do something at the ASL 3 and ASL 4 level. This may be the thing that kind of unbounds it from doing so. So going forward, certainly this modality of interaction is something we have tested for and that we will continue to test for in RSP going forward. I think it's probably better to learn and explore this capability before the model is super capable.
Yeah, and there's a lot of interesting attacks like prompt injection, because now you've widened the aperture so you can prompt inject through stuff on screen. So if this becomes more and more useful, then there's more and more benefit to inject stuff into the model. If it goes to a certain web page, it could be harmless stuff like advertisements, or it could be like harmful stuff, right?
Yeah, I mean, we've thought a lot about things like spam, CAPTCHA, mass there's all, every like, one secret I'll tell you, if you've invented a new technology, not necessarily the biggest misuse, but the first misuse you'll see, scams, just petty scams. Like you'll just it's like a thing as old, people scamming each other. It's this thing as old as time. And it's just every time you got to deal with it.
It's almost like silly to say, but it's true. Sort of bots and spam in general is a thing as it gets more and more intelligent.
Yeah,
it's
just
harder and harder to fight.
There are a lot of like I said, like there are a lot of petty criminals in the world, and it's like every new technology is like a new way for petty criminals to do something something stupid and malicious.
Is there any ideas about sandboxing it? Like, how difficult is the sandboxing task?
Yeah, we sandbox during training. So, for example, during training, we didn't expose the model to the internet. I think that's probably a bad idea during training because, the model can be changing its policy. It can be changing what it's doing, and it's having an effect in the real world. In terms of actually deploying the model, right, it kind of depends on the application. Like, sometimes you want the model to do something in the real world, but of course you can always put guardrails on the outside, right? You can say, okay, well, this model's not going to move data from my, model's not going to move any files from my computer or my web server to anywhere else. Now, when you talk about sandboxing, again, when we get to ASL 4, none of these precautions are going to make sense there, right? Where when you talk about ASL 4, you're then the model is being kind of, there's a theoretical worry the model could be smart enough to break it, to kind of break out of any box. And so there we need to think about mechanistic interpretability, about, if we're going to have a sandbox, it would need to be a mathematically provable sandbox. That's a whole different world than what we're dealing with the models today.
Yeah, the science of building a box from which ASL4 AI system cannot escape.
I think it's probably not the right approach. I think the right approach, instead of having something, unaligned that like you're trying to prevent it from escaping, I think it's better to just design the model the right way, or have a loop where you look inside the model and you're able to verify properties, and that gives you an opportunity to like iterate and actually get it right. I think containing bad models is much worse solution than having good models.
Let me ask about regulation. What's the role of regulation in keeping AI safe? So, for example, can you describe California AI Regulation Bill SB 1047 that was ultimately vetoed by the governor? What are the pros and cons of this bill?
Yes, we ended up making some suggestions to the bill, and then some of those were adopted, and we felt I think quite positively about the bill by the end of that. It did still have some downsides. And of course it got vetoed. I think at a high level, I think some of the key ideas behind the bill are, I would say, similar to ideas behind our RSPs. And I think it's very important that some jurisdiction, whether it's California or the federal government and or other countries and other states, passes some regulation like this. And I can talk through why I think that's so important. So I feel good about our RSP. It's not perfect. It needs to be iterated on a lot, but it's been a good forcing function for getting the company to take these risks seriously, to put them into product planning, to really make them a central part of work at Anthropic, and to make sure that all of 1,000 people, and it's almost 1,000 people now at Anthropic, understand that this is one of the highest priorities of the company, if not the highest priority. But one, there are still some companies that don't have RSP-like mechanisms, like OpenAI, Google did adopt these mechanisms a couple months after Anthropic did. But there are other companies out there that don't have these mechanisms at all. And so if some companies adopt these mechanisms and others don't, it's really going to create a situation where, some of these dangers have the property that it doesn't matter if 3 out of 5 of the companies are being safe. If the other 2 are being unsafe, it creates this negative externality. And I think the lack of uniformity is not fair to those of us who have put a lot of effort into being very thoughtful about these procedures. The second thing is, I don't think you can trust these companies to adhere to these voluntary plans on their own, right? I like to think that Anthropic will. We do everything we can that we will. Our RSP is checked by our long-term benefit trust. So we do everything we can to adhere to our own RSP. But you hear lots of things about various companies saying, "Oh, they said they would give this much compute and they didn't. They said they would do this thing and they didn't." I don't think it makes sense to litigate particular things that companies have done. But I think this broad principle that, like, if there's nothing watching over them, if there's nothing watching over us as an industry, there's no guarantee that we'll do the right thing, and the stakes are very high. And so I think it's important to have a uniform standard that everyone follows, and to make sure that the industry does what a majority of the industry has already said is important and has already said that they definitely will do. Right? Some people, I think there's a class of people who are against regulation on principle. I understand where that comes from. If you go to Europe and you see something like GDPR, you see some of the other stuff that they've done. Some of it's good, but some of it is really unnecessarily burdensome, and I think it's fair to say really has slowed innovation. And so I understand where people are coming from on priors. I understand why people start from that position. But again, I think AI is different. If we go to the very serious risks of autonomy and misuse that I talked about, just a few minutes ago, I think that those are unusual and they warrant an unusually strong response. And so I think it's very important. Again, we need something that everyone can get behind. I think one of the issues with SB 1047, especially the original version of it, was it had a bunch of the structure of RSPs, but it also had a bunch of stuff that was either clunky or that just would have created a bunch of burdens, a bunch of hassle, and might even have missed the target in terms of addressing the risks. You don't really hear about it on Twitter. You just hear about kind of, people are cheering for any regulation, and then the folks who are against make up these often quite intellectually dishonest arguments about how, it'll make us move away from California. Bill doesn't apply if you're headquartered in California. Bill only applies if you do business in California, or that it would damage the open source ecosystem, or that it would, it would cause all of these things. I think those were mostly nonsense, but there are better arguments against regulation. There's one guy, Dean Ball, who's really, I think a very scholarly analyst who looks at what happens when a regulation is put in place and ways that they can kind of get a life of their own, or how they can be poorly designed. And so our interest has always been, we do think there should be regulation in this space, but we want to be an actor who makes sure that regulation is something that's surgical, that's targeted at the serious risks, and is something people can actually comply with. Because something I think the advocates of regulation don't understand as well as they could is if we get something in place that is that's poorly targeted, that wastes a bunch of people's time, what's going to happen is people are going to say, see, these safety risks, they're, this is nonsense. I just had to hire 10 lawyers to fill out all these forms. I had to run all these tests for something that was clearly not dangerous. And after 6 months of that, there will be a groundswell, and we'll end up with a durable consensus against regulation. And so I think the worst enemy of those who want real accountability is badly designed regulation. We need to actually get it right. And this is, if there's one thing I could say to the advocates, it would be that I want them to understand this dynamic better. And we need to be really careful, and we need to talk to people who actually have experience seeing how regulations play out in practice. And the people who have seen that understand to be very careful. If this was some lesser issue, I might be against regulation at all. But what I want the opponents to understand is that the underlying issues are actually serious. They're not something that I or the other companies are just making up because of regulatory capture. They're not sci-fi fantasies. They're not any of these things. Every time we have a new model, every few months, we measure the behavior of these models, and they're getting better and better at these concerning tasks, just as they are getting better and better at, good, valuable, economically useful tasks. And so I would just love it if some of the former, I think SB 1047 was very polarizing. I would love it if some of the most reasonable opponents and some of the most reasonable proponents would sit down together. And I think that the different AI companies, Anthropic was the only AI company that felt positively in a very detailed way. I think Elon tweeted briefly something positive, but some of the big ones like Google, OpenAI, Meta, Microsoft were pretty staunchly against. So I would really like is if some of the key stakeholders, some of the most thoughtful proponents and some of the most thoughtful opponents would sit down and say, how do we solve this problem in a way that the proponents feel brings a real reduction in risk, and that the opponents feel that it is not hampering the industry or hampering innovation any more necessary than it needs to. And I think for whatever reason that things got too polarized and those two groups didn't get to sit down in the way that they should. And I feel urgency. I really think we need to do something in 2025. if we get to the end of 2025 and we've still done nothing about this, then I'm going to be worried. I'm not worried yet because, again, the risks aren't here yet. But I think time is running short.
Yeah, and come up with something surgical, like you said.
Yeah, exactly. And we need to get away from this intense pro-safety versus intense anti-regulatory rhetoric, right? It's turned into these flame wars on Twitter, and nothing good's going to come of that.
So there's a lot of curiosity about the different players in the game. One of the OGs is OpenAI. You've had several years of experience at OpenAI. What's your story and history there?
Yeah, so I was at OpenAI for roughly 5 years. For the last, I think it was a couple of years, I was vice president of research there. Probably myself and Ilya Sutskever were the ones who, really kind of set the research direction around 2016 or 2017. I first started to really believe in, or at least confirm my belief in the scaling hypothesis when Ilya famously said to me, the thing you need to understand about these models is they just want to learn. The models just want to learn. And again, sometimes there are these one sentences, these Zen koans that you hear them and you're like, that explains everything. That explains like 1,000 things that I've seen. And then I ever after I had this visualization in my head of like, you optimize the models in the right way. You point the models in the right way. They just want to learn. They just want to solve the problem, regardless of what the problem is.
So get out of their way, basically.